Hey guys, it's Cameron here, aka the Currency Kid. I made a video on consensus algorithms in regards to blockchain, and I want to share that with you guys. And I try to keep it as less technical as I could. Try to just dumb it down and just make it a little bit easy to understand. So when trying to figure out what a consensus algorithm is in blockchain, really the question you're asking is how do thousands of users or machines on a peer-to-peer network come to an agreement? When you're looking at something like a blockchain, it is a peer-to-peer distributed network. There's no CEO, there's no central authority dictating what happens and what's right and what's wrong. It's really spread out through thousands of people, thousands of users. And once again, the question is how do all those users or machines come to an agreement on a network like that? So right off the bat, just some written definitions of consensus algorithms. So a consensus algorithm is a process in computer science used to achieve agreement among distributed systems. Consensus algorithms are designed to achieve reliability and agreement in a network involving multiple nodes. So once again, goes back to that question here: how do we come to agreement in a network with multiple nodes or parties? So if you're asking what a node is, that's my next point here. So really, to understand consensus algorithms from the ground up, you have to understand what a node is. A node is a part of the network. So some written definitions on nodes here. A node is basically a device, like a computer. It could be a phone, computer, but it's a device that contains a full copy of the transaction history of the blockchain. What the nodes do is they check if a block of transactions coming in are valid, and they accept them or reject them collectively. All the nodes save and store the blocks of transactions, and they store all the blockchain transaction history. The nodes broadcast and spread this transaction history to all the other nodes that may need to synchronize with the blockchain and that need to be updated on transaction history. So the nodes all the nodes, all the machines, all the parties, they all need to come to consensus. They all need to come to agreement on transactions, on the history of the blockchain. As owners of nodes willingly contribute their computing resources to store and validate all the transactions, they have the chance of collecting transaction fees and earn a reward in the underlying cryptocurrency for doing so. So Bitcoin, for example, all the nodes, basically the miners, they all contribute their computing power to validate the transactions and then store the transactions between all the other nodes and miners so everyone has a copy, and in return they receive Bitcoin as a reward for them doing so, for securing the network. Ethereum right now is doing the same thing. Every blockchain has a consensus algorithm, and what they're all doing is they're all verifying the transactions, updating them all, making sure that every node has a copy of them, and then the ones that did that get a reward. So here's kind of a visual here. Here's 10 computers. A blockchain is going to have a lot more than 10 computers. Some have several thousands, tens of thousands. So just imagine each one of these computers represents 1,000 different computers. So basically this is an example and a visual showing 10,000 computers all agreeing that 1 plus 2 equals 3. They're all agreeing. There's not one computer that's disagreeing. They all have a copy of that. They all have a copy of the transaction before that and before that and before that. And all of them are in agreement that this transaction is accurate and that the ones before it have been accurate as well. To look at it on a bigger picture, so we'll start from the top, just to give you guys a visual here. So at the top, we have transactions that are being broadcast onto the network. You have everyone making transactions, sending Ether, sending Bitcoin, sending NEO, whatever they're sending, trying to make transactions, trying to execute smart contracts, whatever they're trying to execute on the network. It gets broadcasted to the network. You have all these nodes here that are verifying if the transactions are accurate. They're storing a copy, and then they're making sure that every other node on the network has a copy and that everyone is up to date. and that there's no one missing any information, and that everyone has a copy, an immutable copy of everything that's happened in the past and everything that's happening now, and that every node is up to date on the network so far. And then the last transactions that just happen, they get verified into blocks of transactions below. So the transactions come into the network, they get verified, making sure they're legit, and they get copied. Every node has a transaction history. Every node gets a copy of these new blocks that are created. And these blocks here are added onto the old transactions. So the ones that happened 20 minutes ago, 10 minutes ago, whatever the block times are, these blocks that come through the network from transactions get validated and stored across all the nodes on the network and saved on top of the ones before. So the entire network comes to consensus again. You hear the word consensus a lot, basically meaning everything coming, basically meaning coming to an agreement. So there's a couple different types of consensus algorithms, and more are being developed as we go. I'm not going to get too much into detail, but I'm just going to go over the basic ones. First one really is that came out, Bitcoin made it popular. It was the first consensus algorithm. Ethereum is using it now. They're trying to convert over to proof of stake. But you have proof of work. So here's some machines right now. These are miners. Go down here. So proof of work is a mining process in which a user installs a powerful computer or mining rig to solve complex mathematical puzzles. So computers and miners all over the world are using these computational powers to compete and solve equations. So the nodes that solve these equations get to verify the blocks that we just talked about, or group in transactions, and in return they're awarded coins for their respective cryptocurrency. So proof of work, just imagine a bunch of machines out there all using electricity, and they're all using their computational resources to compete to verify or to solve a mathematical puzzle. And by doing so, those nodes get to verify the transactions and verify a block of transactions. They get to post them to the network. All other nodes in the network need to get a transaction and get up to date. And then the ones that did that and verified the transactions get a reward in whatever that cryptocurrency is. Next, we have proof of stake. Ethereum is trying to transition over to proof of stake right now. I put a picture of a bunch of coins right there, just really giving you a visual that you're staking your coins. When you stake something, you're putting something at risk, or if you're staking your chips on a poker table, you're putting them up, to be taken or to be used against. So proof of stake states that a person can mine or validate block transactions according to how many coins he or she holds. This means that the more coins owned by a miner, the more mining power he or she has. This is instead of how much computational power you have. So it's more really what you hold in regards to the network. If you Ethereum, for example, if they're going to be doing proof of stake, it's not so much how powerful of a machine you have to solve these computational power problems. It's more of what you have, how many coins you have in the Ethereum project. So you're staking your coins, and you're getting the computational power in return instead of using miners. So if a staker or a node validates a fraudulent transaction, they lose their holdings as well as their rights to participate as a foregoer. I think that's a spelling error there. Either way, they lose their rights in the future to validate transactions. So if somebody stakes 32 Ether and they do some fraud, they validate some wrong transactions, they can lose a portion or all of their coins that they staked. So there's a financial benefit for you not to try to fraud or misvalidate any transactions on the network, because by doing so you're losing what you staked, what you put at risk. Excuse me. Another one, you have delegated proof of stake, pretty similar. So delegated proof of stake, the blockchain system uses a limited number of nodes to propose and validate blocks to the blockchain. This is meant to keep transactions processing fast rather than using several hundred or thousands of nodes. So we talked about before, um, when you're validating a blockchain or when you're validating blocks and transactions, every node in the network needs to get a copy of everything that happened. And if you're doing that amongst thousands and thousands of nodes at a single time, it can be extremely hard and slow for every single node in the network to verify everything that's going on at one time. So delegated proof of stake is basically saying, hey, let's limit the number of nodes. And instead of making 10,000 nodes verify the network at every single time, we have 21 people or 21 nodes doing that. So people in that cryptocurrency community vote for the witnesses or the nodes to secure their computer network. So those that hold the token or the coin, I should say, they vote for who, the 21 delegates, for who they are and who's validating the transactions. But if a witness starts acting maliciously or stops doing a quality job securing the network, the people in the community can remove their votes and essentially fire those bad actors. So if you have 21 delegated nodes on the network validating transactions, and one of them is being fraudulent or not doing their job, they could be voted off. So obviously there's an incentive to validate accordingly and do your job so that you're continuously being one of those nodes, keeping your position and getting rewards in the meantime. And once again, just like proof of stake, there's slashing or consequences for posting false and bad transactions. You can lose a portion of your stake, let alone losing your spot in line to verify transactions. So there's a financial incentive for people not to be malicious actors in the space. There's first of all, there's many more consensus algorithms. I'm not going to go over every single one. Maybe I will in another video. But those are the few main ones we have now that are at the forefront, and a lot of cryptocurrencies in the top 10 use those algorithms. Something to talk about is the scalability trilemma a lot of people talk about. It's very hard. Some people say it's impossible to get everything right on a blockchain consensus algorithm. The main three that are hard to come across and get right are scalability, decentralization, and security. It's very hard to get all three of those at the same time. Decentralization, it's an important factor. It's a core tenet upon which the majority of this community is built upon. Decentralization is important because it enables censorship resistance and permits anyone to participate in a decentralized ecosystem without prejudice. So once again, a decentralized system like a blockchain, there isn't one person or 5 people that get to dictate everything that happens. That's one of the major benefits of blockchain. You also have scalability. It concerns the ability to process transactions on any given network. If public blockchains are to be used by the masses, then they must be able to handle a scenario in where there are millions of users on the network. That's what decentralized proof of stake is trying to attack. If you have 10,000 nodes needing to verify millions and millions of people making transactions all day long and needing to get a copy of everything that's going on, 10,000 different nodes trying to have a copy of millions of people doing things at one time is it can clog up the network, and it's very slow. So if there's an argument, if blockchains want to scale, they need to bring down that node count, or at least put them in different chunks, which is called sharding, which I'll put in another video. You have security as well. It pertains to the immutability of the blockchain ledger and its general resistance to attacks. 51% attacks, IBL attacks, DDoS attacks, etc. And I'll put that in another video. But a blockchain is basically useless if it could be hacked and the ledger of everything that happened in the past can be changed, edited, or false transactions can be placed. No one's going to use a blockchain if there's no security and people are being able to double spend, attack the system, fraud it. So right here with security, that's the argument for proof of stake with 10,000 networks, it's very hard for 51% of the network to take over the other 49% and, do attacks, commit bad transactions, change the history of the ledger, etc. It's very hard with 10,000 nodes. A lot of people think it's a lot easier with that 21 nodes in delegated proof of stake we talked earlier. And there's a big argument as well that in proof of work, which we talked about earlier, a lot of people think that has a security issue and isn't as decentralized because it's basically a bunch of people that are. Let me go back. Basically with the proof of work, a lot of people are thinking that a large portion of the mining power in the world of those miners are controlled by China, are controlled by large mining pools. So there could be a chance that one day they can pool their resources together and take over 51% of the network. So that's really the next slide here. There's a debate on which consensus algorithm is really going to make it. So that's why a lot of people are, a lot of blockchains are using these consensus algorithms, but they're having spin-offs and doing hybrids. With proof of work, a lot of people think it's using way too much electricity. You have these thousands and thousands of mining machines competing with their computational resources trying to solve these problems. A lot of people think it's too slow just because the number of nodes required to validate. And a lot of people think it's not very decentralized because of that those mining pools we talked about where people are putting together their computational resources. Proof of stake, once again, you have 10,000 nodes. They all have to verify everything that's happening on the everything that's happening on the blockchain. It's hard to scale, needing everyone to verify what's going on at all times, which is what delegated proof of stake is trying to solve. But a lot of people think that delegated proof of stake may not be truly decentralized because with 21 nodes, I believe the network has for a project like EOS, 21 people, they think, oh, well, a cartel can be formed. If you get 15 people, you have over 51% of the network and they can form a cartel and they can take over. And having 10,000 different nodes, it's a lot harder to take over half of those than it is to take over half of 21. So there's a large argument here on what the winning consensus algorithm is going to be. Could be one that we've never heard of, could be one that gets invented 5 years from now, or it could be simply proof of stake with a couple layer 2 solutions on top of it. The future is unknown. We will see which one of these consensus algorithms is the most secure, decentralized, and can scale, solving that scalability trilemma. So once again, to go back to the visual, just to kind of finish things up, you have a large network. Let's say you have 10,000 nodes. You have millions of people using a blockchain. They're all posting transactions, using smart contracts, using games. All these transactions coming into the system need to be validated, and they need to be put on a blockchain so that basically with the blockchain, the entire history of everything that happened is stored. It's been proven to be accurate, and it's immutable dating back. So all these transactions that are coming in now and being broadcast to the network, all these nodes are verifying those. They have a copy of everything that's happened before, so they could take these new transactions coming in. They can verify them. They can put those into new blocks and add those on to the blocks of everything else that's happened in the past. So the entire network is coming to consensus. They agree that everything that just happened recently is accurate, and everything that happened before that is accurate. And you have a blockchain that has a ledger that's immutable and that has been proven to be accurate, and every single node on that network has come to consensus, and that the truth has been told. I hope this video has been pretty accurate and pretty educational for you guys. And I know I rambled a little bit, but I wanted to get the point across. So I'll probably do another video explaining different kinds of consensus algorithms, but this one I just wanted to really explain what consensus algorithms are. So thanks for watching, guys. I appreciate it.